As you'll see on Google Classroom, there was a slight design error in this second one, or in not the second one, but in number 14. You're supposed to be 3, negative 16 instead of positive 8. Missed a sign. Double. But that still harkens to number 14 and 15, which are two of our most difficult problems on here. Okay? And notice this hint that was given. This was just kind of as a, hey, refresh your memory. That way I didn't have to, help every single person whenever they got this one because it's such a difficult question. Just kind of a little jog your memory saying, hey, go from vertex to standard to factor. Because we're starting out with the information of our vertex, and we want to end up with these x-intercepts. That's what the question asks for, and that means vertex to factored form. And we're going to need a little bit more room to do that. So this vertex is negative 3, negative 16. That's my vertex. And I eventually want to go to factor form, but before I can do that, I've got to start with vertex form, which means we have to have x. I flip this sign, making it minus 3, quantity squared, minus 16 equals y. And you sit there and wonder, what about that number out front? What about if it opens up or down? I alleviated that worry and just said, hey, make x equal 1. Because if not, that just opens up a whole other can of worms. So before I can get factored form, I need standard form, really. That's what I need. So I've got to put this in standard form, which means I've got to put everything back together. I have to take this exponent and work it out, meaning I have x minus 3 times x minus 3. And then my minus 16 hanging out on the end of my y. Well, when I multiply this out, I get x squared minus 3x minus 3x. I know I can combine those like terms. I'm going to go ahead and do it now. Gives me minus 6x. And then my final multiplication is plus 9. Minus 16 equals y. Notice I dropped the parentheses on the left because we are completely done with all the multiplications. There's my like terms. I get x squared minus 6x equals negative 7. Minus 7 equals y. Okay? And it took me all these steps to go from vertex to standard. And that's not even what they wanted. That was an earlier problem. Okay? Vertex to standard. We want to now make the jump from standard to factor, okay? And that's the jump we learned last unit. We have to run this through our box method. What that means is we're looking for factors of negative 7x squared that add together to be negative 6. Well, that's a pretty easy one. It's got to be negative 7x and positive 1x. They multiply to be negative 7x squared. They add to be negative 6x. We're going to run that through the gauntlet of our box method. X squared, negative 7, negative 7x, 1x. We get x minus 7, x plus 1. Okay? Those are our two pieces. And we know that once we get right here, what we're really asking is, what can make this y equal 0, which is where we split our problem and we set each of our factors equal to 0, okay? Or, as a lot of you have learned by now, you can just shortcut. What I mean by that is I know this is going to flip signs because it's in parentheses. So it's going to give me the 0 of 7, 0. Whereas this other side is going to present the 0, negative 1, 0. So if you know the shortcut, there's your zeros for your answer. If you don't, remember the way we work this out is x minus 7 equals 0, add 7, x equals 7. That tells me that whenever x equals 7, this will be 0, and 0 times anything is 0, meaning that's when my y is 0. Similarly, x plus 1 equals 0, minus 1, x equals negative 1. When x equals negative 1, this y equals 0. Okay? On to number 15, we're going the opposite direction. Given the zeros, find the vertex. I like this direction a little bit better, just personally. Given the zeros, find the vertex. Okay, so our zeros are -6, 0, and 2, 0, if I remember correctly. Yep. Again, A is going to equal 1. Don't have to worry about that. But what we do have to worry about is how do we go from zeros to vertex? Well, it's the opposite direction that we were going in. On this problem, we're starting with factored. We got to go to standard and then to vertex. Well, from our zeros to factored form isn't a giant leap. We just go opposite signs, meaning we're going to have x plus 6 and x minus 2 equals y or f of x or whatever else you'd like to have there. Okay. Notice if we were starting here with our factored form and asking for the zeros, we'd flip to be exactly these. That's how you know you did it right. A is going to equal 1. I'm not going to write it. It's just 1 times anything is that thing. X squared, -2x, 6x. I know I can combine these to be like terms. -2x and positive 6x is going to be a positive 4x. So I'm just going to erase what was already there and make it a positive 4x. And then do my last multiplication of -12. I should have stopped and explained why I did that better. Remember, what we're doing is we're starting with factored and going to standard. Well, to get standard, we got to put everything back together. Because factored pulls everything apart, divides everything out. Standard, we want everything put back together in our nice, neat ax squared plus bx plus c form. And now we're ready to go from standard form to vertex form. And that's our completing the square method. It's those new steps. And the first of those new steps is to get that constant over to the other side. Okay? First of those new steps is to get that constant over to the other side. X squared plus 4x equals y plus 12. Okay? Next step, we have to make a equal 1. And it already is. It's been a while since we've seen one of these. We've been doing more complicated ones than this. So now we're actually ready to figure out what we need to add to both sides. X squared plus 4x plus blank equals y plus 12 plus blank. Okay? Over here in our scratch work, we need 4 over 2 quantity squared, which is 2 squared, which is 4. That's what's going in the box on the left. And because we didn't pull anything out, we don't have to worry about compensating for our weights. There would just be a 1 out here. And 1 times 4 is still just 4. So this time when we added 4 to the left side, we actually added a regular 4. Wasn't a tricky one. Now we're ready to factor the left-hand side. Again, if you're a box method person, you'd be looking for factors of 4x squared that add to be 4x, which is going to be 2x and 2x. We'd run it through our box method. Get x plus 2 and x plus 2. Now, why did I speed and fly through that so quickly? 1, we've been doing a bunch of them. Those are as easy as they come. And 2, because I like the shortcut. The shortcut means I square root this piece, which gives me x. I take the sign of the middle piece plus, and I square root whatever I just added, because it's automatically a perfect square. Square. I quantity square that whole thing, and that's my shorthand, shortcut, not shorthand, my shortcut. Y, this would be 12 plus 4 is plus 16. Okay? Final step to get vertex form. X plus 2 quantity squared. We want to move that 16 back over now that we're done with it. Okay? And this gives us our final answer of our vertex. For our vertex, we flip this sign and we keep this one. Meaning we have -2, -16. Okay? Flip that sign, keep the other one.